Good. Nice. Did you come to my talk yesterday as well? No. Yes. Okay. So yesterday was my favorite topic. Today I'm talking about something new for myself. I'm not an expert in functional programming at all. Like whenever I saw like a monad, it was like, ooh, I don't want to touch it. And is any one of you using functional programming or knows that he uses functional programming? Yeah, come to me and have a discussion if I'm wrong, right? Oh, yeah. So that's my Twitter handle if you want to yell at me afterwards. Why am I talking about a functional fashion or functional style is exactly that. I'm not too good in functional programming, so I want to emphasize that we are not talking about functional programming today. Well, this is a nice effect. So I'm coming from Estonia. I work for JetBrains. I'm a developer advocate there for a Kotlin team, but I also work with different other products. And I've been doing about 20 years of Java in my professional development career. And we talk about three things today. We try to combine. I was redoing this presentation multiple times during the past month, and I'm still not happy the way I can combine the three notions here. So Kotlin is the language for the JVM, initially for the JVM. A lot of people still think it's for Android. It's also for Android, but it was initially created for the JVM as a better Java, with some modern constructs in mind that enables some of the things we are talking about today. The other interesting project we have is Ktor, which was created as a test bed for Kotlin programming language, including coroutines library. Because when we started it, we needed some project to actually test the new ideas, the new constructs. So Ktor started as a test bed, and then it somehow extracted into an open source project, and JetBrains started to build products on top of that. And it's now like a separate product, not really inside a Kotlin team, but a lot of people think it's like the same, Ktor and Kotlin, but it's actually different teams and different goals. And the last one that I'm talking today, last project that I'm talking today, is this Arrow.kt. How many of you know about Arrow.kt or using Arrow.kt? You are much more familiar with it. I'm telling you, you're much more familiar with it than I am. I'm just, I like what those people are doing, and I think it really complements the projects in some parts. Okay, so that's my story with functional programming. Every time I see someone talking about it, I'm like, okay, I don't want to. It's nice, it's interesting, it's like math, but it actually reminds me my story with learning music or learning playing the guitar. I saw my father playing the guitar, and I also wanted to do that. And every time I asked him, can you teach me? He gave me a picture, or a book of music theory. And I'm like, okay, probably not play the guitar. And with functional programming is the same. I was like looking from the side because I was not applying it in any way. And whenever I wanted to learn about it, I was reading this real books or listening for someone talking about functional programming, and then I could not find a relation from my projects and like the topic, the functional programming topic at all. And I thought it's like, it's sort of it's an interesting topic, but it's an overhead for my situation. And until I actually started programming in Kotlin without Spring. How many of you used Spring in your life? Everybody. Okay. So until I actually saw some interesting projects where the code looked nice, and I thought, wow, this is how I want to write the code. And I didn't think about it as functional programming. But after that, I also saw the book where they talked about the guiding principles of FFP and started without the math behind it, right? Just the style, just the like how you should think about your code and so on. And have you seen this book? It's a new one. It's a really new one. If you haven't seen it, go and check. I think it's still in beta even, but it's by one of the Arrow.kt authors, Alejandro. And I think it's very interesting. I have not read it fully yet because it's so new, but there are some interesting approaches or those principles described. So first of all, the extensive use of the main language. It doesn't speak about the FP, right? It's just a common approach. It's common sense, right? It can be used in procedural programming as well. Why not? You're going to use the domain language. You're going to name the variables correctly and so on. The other principle, be explicit, right? If you're in, like, tell in the code what the intent is, or prefer data manipulation over the complex data control flow. If you're applying FP principles already, you probably know what it means. Anybody? Tell me. Let's have a conversation.
Operate on the list and apply the same thing to all elements on the list.
Yeah, but over complex control flow, what does it mean? Does it? I would say, like, the control flow, the first thing that you think about is if and for loops, right? But this is a local control flow. This is not a complex one. The complex one is the non-local jumps, exceptions, right? This is something like, if you have been programming in Java for 10 years, this is the thinking you have. If whenever something goes wrong, you just jump out with an exception and catch it somewhere, right? And if you get rid of that, suddenly your style starts changing. If you think about the unexpected situations as data. So you just pass the information further and someone deals with it without those local or non-local jumps in the code. The other one, the last one, is about controlling the effects and dependencies. We're gonna check that in a moment. So, about the domain. If we think about Ktor or any Kotlin projects there, you describe your servers in the terms of the domain that we are in, right? We are describing the server, we're describing the routes, we're describing the response logic and so on. Therefore, we have those interesting blocks. Like, it's just one example. Have you used Ktor before? We're going to have a very quick look into what it is as well, since so many of you haven't seen it. But also the extra types, right? So, So describe the server using the vocabulary, and also, whenever possible, stick to the domain types, or like model your data with types as well, even if you have just one value, and the language actually enables that. So if you have used Kotlin before, do you know what up there is written, like why it looks like a JSON? Tell me. What are the syntactical constructs that enable this? DSL is kind of a generic term, right? There is no feature in the language that is called DSL. It's a trailing lambda, passing in a trailing lambda as a parameter, but since it's the last parameter in the call of the function, it can be written without the parentheses. So, like, if we go into the IDE, just for a second, assume we have nothing here, whatever. So if we have a function, fun foo, and there is a functional parameter or a block, should I increase the fonts? It's okay? I'm going to increase it like this. So if we define something in the function as a functional parameter, like this, then we can actually invoke this function by, well, yes, we can just put the parentheses in here and write the lambda right here, like print line, hello, whatever. But even the ID tells you that you can actually omit the parentheses and write it like this. Consequently, we get this first step in building the DSL. But of course, if it's just a parameter, it's not enough because we want to create some, like, we want to pass some context across those nested blocks. And therefore, it's sometimes possible to supply this context with some class, let's say, class, whatever, context, like this, and say that this lambda should be an extension to the context so that whatever something is happening inside that lambda is going to be present within the context of this object, right? So if we have a field in here, or a property, then we actually have access to that property through the implicit variable, foo, right? That's just a syntactical feature. Kotlin as a language does not provide you so many unique features. It rather combines different nice features from the other languages, but this is probably the single one that I haven't seen in the other languages. Sorry? Lambda with the receiver is in Swift? Okay, I wasn't aware. Right, nice. Okay, let's go back to the slides. Okay, that was the first principle. The other principle was about the, sorry, I didn't switch off the notifications, about being explicit. So the two functions here, or the two signatures, is the same function. Effectively does the same, but the latter one is more explicit. Why? Anyone? Talk to me. It's probably in the early morning. It's hard. But it's lunch coming soon, right? So what do you think? Why the second option is more explicit? It's kind of obvious. There is more code. But why? What does it mean?
It's more obvious when an error occurs, or what type of error it could be, for example.
Right. So it's more obvious what kind of error. Rephrasing a little bit, there is an indication that something might go wrong, right? It just not just returns the type, but it tells you that there is a wrapper that might contain the value and it might contain the error. Arrow users, something familiar for you, right? Correct. But also, there is additional annotation declaring a context. And that context is, it kind of indicates what are the services that are needed for this function execution, right? So essentially, this function does the same, but it's more explicit about its behavior, right? And about the requirements as well, which goes kind of hand in hand with the last principles of controlling the dependencies, right? We say here that this function to execute actually needs a database service, and well, it will be compiler controlled as well. If you haven't heard about context receivers in Kotlin, it's an experimental feature since Kotlin 1.6.20. It's still experimental, so you have to enable in your configuration, but well, it works quite nicely already, and we are collecting the feedback about it. Data manipulation over the complex control flow, as I already said, instead of throwing the exceptions and trying to handle them in one single place, especially when you don't have checked exceptions in the language, is not a good idea because it's hard to reason about the complex data flow or control flow, what the program is doing actually. And well, instead we manipulate the data and check the result, what do you think, what are the consequences of getting rid of the exceptions as complex control flow and using data for transmitting the information about the failures? Or like in any way, using data for transmitting the information across the invocation chains. Mario?
Yeah, I honestly prefer the second option because otherwise with exception, first of all, okay, theoretically you lose referential transparency, which is not a good thing, but this is more the theory, I understand. But the fact is that you have two different channels to convey the error or the result. The error is conveyed through the exception stack, and the result is the object returned by the loop. If you return either the result or the error as the return value of the function, then you have a more coherent way to deal with both situations.
I'm not sure if I can summarize your comment, but well, what I wanted to lead to is that the effect of using the data for transmitting the information is also the immutability aspect of it. Because if you start passing the information as a flag or anything else, you want it to be immutable so that nobody else mutates the initial information across the chain. And the other interesting construct, what was already mentioned, is about for loops. So if we specify the boundaries of the loop, we kind of start controlling, how we execute the loops. Instead, we have a function, like basically it's a generator function in here. And if we need to iterate somehow differently, so we need a different sequence, we basically create a different generator function for this, for this functional chain further. Okay. So, and controlling the effects and dependencies, it's also again about a good example in Kotlin is using the context receivers. There could be multiple of them, and as I mentioned, it's an experimental feature. But it's not only about language. When we will see also, like when you're structuring your Ktor project, you want to have control over the dependencies in the application as well. So, but before we actually go into Ktor and Arrow, like a few days ago, I think it's just a good example of thinking when you try to compose your applications in Kotlin. A friend came to me, and he's actually using Kotlin for quite a while, but he was a Java developer before. And I see it as a pattern as well when people come to me asking help, like, can you help us with some small piece of code? It doesn't look that nice, and I want it to look nicer. And the situation was that he had a few resources in his application. I think it was Spring because of some patterns that he used, but they use coroutines, they use some external libraries and so on. And you probably cannot read this code. This is too small, maybe. But I can tell you that there's a huge duplication going on. And he was not happy about it. So basically, he had to duplicate the code 3 times. Why? Because some parts of it were different objects, and they did not share the same interface, and he could not change it. The objects were coming from the implementation from the library, or from different libraries. So basically, he had no control over it. And he wanted to squeeze this code, like to reuse it, right? He didn't want to duplicate it. He wanted to get rid of this duplication. How would you go about this in Java? Because in Java, you can do the same. It's just a Kotlin code or Java written in Kotlin syntax right now. without thinking about the modern possibilities that are present in Java today as well. So his approach was to actually use reflection and cast, whenever he wanted to call a specific function. Let me actually open this code. So that was this is the initial code. Like, there is a domain, there are some classes, it just models the real code. We have this client code that is actually uses those 3 services, and then there is a cleanup part that invokes those separate objects one by one, calling first for the first one, then duplicates for the second one, duplicates for the third one, right? This is something we want to avoid, and one very naive solution that can come is that let's use the when expression, and since Kotlin provides it, we can smartly cast the any type. So basically, since we don't share the interface, let's create the most the most common type, you use it as a parameter, and then cast to the concrete type, then we can invoke something. This kind of gets the job done in terms of getting rid of the duplication, right? Do you agree? But is it nice? Probably not, because you are using what? Reflection. This is something that you want to avoid, right? It's okay. It fits on the screen, right? But you have a bad feeling about it. Instead, you can actually extract those operations into lambdas, and you can do that in Java as well. And this is the thinking you probably don't have if you've been modeling your programs as objects but not functions. So if you start thinking in classes immediately, you think, oh, I need a common interface. You can actually create a common interface and a single operation in there and just delegate to that invocation. But since we have lambdas already in the language, we have functional interfaces, oh, let's use it as a parameter. But then this function that was in the initial domain object is marked with suspend keyword. And this is where, for some people, it breaks, right? I want to call a suspending function from a lambda, but how do I do that? Oh, I need to run blocking call, but how do I pass it as a parameter? How can I define this functional type? And in Kotlin, it's possible by using just this suspend keyword for the parameter as well. So that was the single piece that he missed, actually, or single piece of information that he missed to actually implement the common code without reflection and be able to pass in the block as a parameter. Just checking if you are following. Did you learn something new? Did you? Okay, cool. Not too many of you, but that happens too. Okay, so let's go back to the slides. And yeah, so we basically could, use lambdas as parameters and mark it with suspend keyword, and it solved the issue for him. And the thinking that should have been changed is that you don't have to have the interfaces. You can think of your domain as functions because it's the behavior. And one little piece of information is that you can specify lambda as a suspend lambda in Kotlin as a suspend parameter. Okay, let's talk about Ktor. Most of you haven't heard of Ktor before, right? So I had this assumption, and we can briefly go into there. But instead of live coding, we have everything in slides. So Ktor is a small library. It's not even a framework. We do have framework mentioned in the documentation, but actually it's just a toolkit, a set of libraries that provides you some help or APIs to write HTTP applications. And to create a project, if you have IntelliJ, how many of you are using IntelliJ? Everybody, I think. There is always one Vim user anyway, right? But for those, we have a web-based generator. Okay, you can generate like a Java project, basically like a Gradle or a Maven one, and of course you will have Kotlin in there pre-configured for you and all the dependencies. And once you go from the wizard, you actually have a few options for configuration. You can choose different engines for handling HTTP. So the default one is Netty, and we also have Jetty integration and Tomcat. And there's one interesting option that is called CIO, which stands for Coroutines IO, that is built by the team itself, by Ktor team. And it has some interesting capabilities, not in the performance, but it can compile to native. So consequently, by building a Ktor application on top of CIO, you can actually compile the whole web application into a native binary, which has some also interesting consequences. You probably can take this binary into a small device and start an HTTP server in there. It's experimental, because Kotlin native itself is sort of experimental, and it implements its own garbage collection, which is not the same still as the JVM. I mean, the behavior, they're changing it. The new one is experimental and is going to be compliant, so you don't have to account for your target platform, so it will be the same common Kotlin code that you write for the JVM and for the native. I hope it was not too fuzzy. And there are different options how you configure the application itself, how you provide the environmental variables, and so on. You can have external configuration file, but you can also configure everything in code without the configuration file, and that is actually the default. Also, since it's just like a wrapper or HTTP library, but we never built apps in isolation, it actually provides a few plugins. We call them plugins, but kind of extensions for the commonly used libraries for serialization, for logging, for WebSockets, for whatever you need, maybe. There is a list, and if you need your own, then there is a small API that enables the integration as well. So what effectively happens is that for every plugin, you get an extra artifact in your class path. It's a small one, but it's kind of very modular. So by looking at the configuration file of your project, you will see that, okay, I have those plugins for Ktor in my project as well. And when the app is generated, this is how it looks like. It's all about functions, and the entry point is just the main function, and there is the embedded server. Even if you haven't used Ktor before, you probably will just, by reading the code, will understand what is going on there, right? It starts on the port, on some host. There is a module that is implemented inside the function, and there probably is one place where it needs the explanation why it's an extension function. Because the application class is what provides you the internal access to the environment that the Ktor application is running in. The configuration objects, like if somewhere I want to check what port is open or any property that I have set externally with the configuration, then inside the extension function, I have the access directly to those configuration properties, and I can use them, right? And then I can just describe the routing, the endpoints, and so on. So that's it. There is no, since it's not a framework, you are free to configure your project or structure it the way you want. Just, extract every single function into a separate file and just structure like this, for instance. I'm just calling those extra extension functions from the main extension function of the module. And I can just put them into the project structure. So basically, every extension function that I have here is also an extension function for the application class. So again, I have all those environmental dependencies available inside this call. And then I have to be explicit about what I'm using here. Also, it goes hand in hand with those principles we mentioned before, right? I'm explicit about the intent of using some library. I put it into the class path, but it doesn't magically appear in my code until I actually express the intent. I am installing the plugin with the specific configuration options, and then I can use it in the routing. Plus, actually, Ktor is built on top of coroutines. Everything is asynchronous, and you can, in some files, in some sources, you will see a lot of those arrows as suspending calls on the side. Since Ktor is just an HTTP library plus a few integrations, the team is not actually working on integrating with the infrastructure that much. So if you want to access the database, you're on your own. Which library you like more, you can just start using it as it's a plain code application without any requirements for you. Like if you have used Spring, then Ktor feels very anemic in this case. And for instance, here I'm using exposed library, and it provides a DSL for talking to the database. Have you heard of exposed before? Not too many people. It's a very popular library for Kotlin projects, but well, it's not the only one. It's just the project someone is building at JetBrains as a 20% project, but it's quite popular. So we get to Arrow and why I like it. I'm not an expert, so if you are using it, probably will have a comment and let's talk. I do have a sample application, but I don't think I will be able to cover it fully. And since I'm not an expert, I decided just to take the screenshots of it and talk a little bit about different pieces that I like. Well, first of all, there is a domain model for this application. It's available on GitHub. I will have a link in the slides as well. But that domain model is described as immutable data. That's an interesting property according to the principles we mentioned earlier. Then it uses also like copy or optics, like copy is given because you have data classes, and optics is something that is coming from the Arrow library that is a little bit more powerful and versatile than just the copy method provided by the compiler. Also, you can notice that there are some extra data types. Well, anyone can tell why is it good to wrap the primitives like that into a class? Because you don't want to have your types a stringly type, right? You want to have some domain knowledge about the specific property, value, or a number, or anyway. It also has some interesting consequences because for the classes you can express the requirements, and Arrow provides a meta framework like a Kotlin compiler plugin that can check the requirements. So if you're passing in a negative value, but your requirement is that this value should be positive, then it will be a compiler error, not a runtime error, which is very good. So you can add some more validation to your code. And the other interesting interface that the application has is this warehouse interface with a single function. Why is it good to model your functionality in terms of interfaces? What do you think? What do you think? It's an obvious question, or I expect an obvious answer as well. Testing. Good for testing, because we might be talking to remote APIs, and in development we want to change the implementations. So it simplifies testing. Also, we use information about the problems as data, not exceptions. And yeah, which goes hand in hand with the principle of the data manipulation over the complex control flow. And the last function here is an extension function. If you're a Kotlin user, you probably know the difference and the effect of it. What do you think, why it's interesting to have something in this functionality as an extension function, but not as a function inside the interface? Any guesses?
Then you don't need to implement it for everything.
So the answer was, then I don't have to implement it, then I can't implement it as well, because I cannot override. It's an interesting difference that should be considered, I think, because for instance, if I'm modeling this interface and I'm giving the user it as an API, but I want some of the API to be set in stone, then I can use this syntactic capability of Kotlin, right? I cannot override it. Although, if I put an extension function inside an interface, then I can override it. Okay, but for this specific example, it's actually composing the validation logic across around the specific functionality of the interface. So if we implement the check availability, the surrounding logic will be still the same, right? So we have control over it. Another interesting effect of extension functions in regards to composition is that we can combine the types. So for instance, we have this billing interface, and then we want to kind of combine the functionality with some infrastructural requirements, like the circuit breaker. Everybody knows what the circuit breaker is? It's kind of a gate. If your application is failing, it's a gate to prevent the external service being overloaded, for instance. So this billing with breaker, the new class that I'm exposing like as billing interface in this function, it's kind of a decorator pattern right now. That composes billing interface with the circuit breaker, and then the circuit breaker right here is its definition. It actually comes from the Arrow library, but you can get circuit breaker implementations from different libraries as well, like Resilience for J, I think, has one, probably with slightly different functionality and behavior, but the idea is the same, right? You gate the failing service, the invocations to this failing service, so that you prevent its failing for good if it's overloaded, for instance. But then you can combine this logic of the circuit breaker with scheduling as well. So you can have an API from Arrow library to actually, describe the logic how you access that external service if it fails. Like retries, scheduling, the retries depending on responses, depending on the error conditions, and so on. So, and obviously you can make it configurable as well if you pass in the parameters through the configuration file. Validation is also an interesting part of Arrow library that I think if you didn't know about it, then you probably should go and learn firsthand. So there is like a function, check availability, and there is a static function, static extension function in there. And when you browse the code, you will see that they use this validated types for indicating that the data is correct and or incorrect, or somehow you have to pass the information further under the same interface. But yeah, let's skip this. I think I'm running out of time in 10 minutes, right? So like when we skim through the validation logic, we will also notice some of the principles that we mentioned before. For instance, conveying the behavior information about the function right here. First of all, this function is accumulating errors, like validated means that they accumulate errors from multiple products in the order. So the domain model I didn't explain at the first slides was that we have an order, and the order has multiple entries, and those multiple entries might be in the different warehouses as well. And the validation for those entries is happening like you probably want to accumulate and check the whole order, not just a single entry. That's why you accumulate all the validation information into a single, data set to expose to the user if something was wrong about the order. Then, since we have entries as a list, we're going to traverse it. So it's going to do it for every element in the entries list, and it's going to do it in parallel, right? So, but this one was simple, but when you look at the picture as a whole, you start seeing those interesting elements or interesting blocks that you haven't seen before if you didn't use Arrow library, like either, or map left, or bind, and so on. And this is the API you have to get acquainted with. So any of the Arrow users can confirm that they're using it? No? Okay, you're trying to. Okay, because when I saw this code, I had the first question, like, how does this work? Like, either probably works like a result, something similar to the result in Kotlin. It's just a different type, and it was confirmed. It's just a little bit more versatile. Instead of requiring you to use a throwable as a type for the error, you can use any type. It doesn't have to be a throwable, for instance. So you can just model your information about the unexpected situations as any data, not as throwables. And then you have these extra functions that unwrap your values inside the validation block one by one. So, one second. Yeah, I wanted to jump into the ID right here because I have this example distilled and extracted. So let's remove the code we had before and uncomment it. So it's the same block, it's just written with the same dependencies but separately. And I want to demonstrate the effects of it. So initially, we could have, like, let's assume that we don't have this when. Sorry? Why is it? Yeah, like this. Let's assume that we are not handling the result in any way just yet. We're gonna start with opening the either, and we know that we need to do some validation inside, right? That's the entry point, and the result will be some bad request type if something goes wrong, and or if everything is good, then a list of entries should return. So basically, this part, list of orders, should make this code compile if I have, of course, a real value in here. Okay, let's return the validation block. And validation block with either means that here we are going to retrieve this entry if it's valid, or if it's not valid, then we're gonna return this bad request type somehow, right? And bind is going to unwrap it. So if we actually specify the type explicitly, it's gonna be an entry with bind. And if we are not doing that, if we remove bind, then the type is actually either. So it just takes the entry out of that, right? So, but it also works as a fail-fast strategy. if, how do I know? Like, I experimented with this. So imagine if I have another block, the same block, just make it compile like this. For instance, I have stages of validation for my data, right, for my order right now. And something fails on the first stage of the validation, then I probably don't want to validate anything here anymore. So it should just exit the block and be done with it. Let's model that. So I instead of actually validating in the first block, or like producing the entry, producing the valid entry, I'm gonna throw the exception, and immediately the IDE will actually tell me, because it's all modeled as types and everything is compiled, then actually the IDE knows that this code is unreachable. Yeah, like, let me see. Why is it? Yeah, I just had the information a second ago. Where is it when you need it? Yeah, returning time parameter has been inferred, nothing implicitly, because it will never finish, right? We're gonna throw the exception. And if yeah, it's an unreachable code. You probably can see it here, right? So if we try to execute this code, we're gonna see when we handle the result for this code, what is going to be? It's going to be left because the validation fails, and the result will be something like meh, right? Let's run it. Will not work. Okay, yeah, because we have the exception right here. Because we had the message, and if we don't, we probably will display this value. Yeah.
I have one comment.
Yeah, comment or question or comment for you.
I have one comment.
Yeah.
I think this is not reachable, not because you use either, it's just because you throw. But I think your idea is if you use the same without bind in the beginning, and you use the same order, and you try to do map, when it's left in the beginning, it's not gonna
Yes, yes, right. So my idea here is that with bind, it will be the fail-fast strategy, kind of the same as you have with nullability in Kotlin, null-safe calls. If you have an object graph and you want to reach the very deep property of that graph, then everything in the middle can be null, and with null-safe call, you're gonna have kind of the same effect. All right, we're gonna have 2 minutes more, right? About the effects and dependencies in the same project, if you have the motivation to check it later, especially if you have used Ktor before and you are interested in integrating with the resources, then Arrow actually provides a resource abstraction, which is very interesting, and this is something that Ktor does not provide out of the box. It's not about functional programming as such, it just uses the same language constructs and abilities to model that. As a result, because normally you just use this embedded server invocation to start the Ktor application, but then you can actually have this dependencies block or model it the way you want it, and model your application itself as a resource, or you can compose different pieces of this application as resources, including the database, including the external service maybe, or interface. So the warehouse and billing service could have been resources, the nested resources as well. And then the whole thing will take care of graceful cleanup as well when your application is shutting down, when, let's say, in Kubernetes or Docker environment, you are getting the exit signal, right? So this one abstraction, it doesn't really tell anything about functional programming. I mean, this resource block. But this goes hand in hand with the principles that you are controlling the resources and dependencies. So I have a homework for you, because we are done with the presentation. There's a very nice talk by Urs Peters, Pick the Best, Skip the Rest, about functional programming, and the book as well. Although it's in beta, it's already almost complete. You can get very nice ideas from there. What I was talking about today is just an introduction into that book. Of course, you get much more ideas and much more information about the foundations behind all those ideas as well. So I didn't mention monads. Now I did, okay. Thank you very much. And if you have questions, comments, ideas to share with me, I'll be happy to listen, and I'm here, so catch me. And now we're gonna have lunch. Thank you very much.